Okay. Okay, welcome to this second workshop. Today we're gonna have a presentation on game engines. But first, how's the work going? How's creating games, game development? How is it doing? Have you come up with any ideas?
Yeah.
Okay. Anybody's using ideas that you had last week? Are you developing further any ideas that you came up with from the last workshop, or is this just complete? Anybody want to share their game idea?
I'll see.
Too shy. Nobody's going to steal it because everybody thinks they have the best idea in the world. Okay. Before Hannes begins, I have one announcement here. Does everybody know Slush conference? Okay, there are a few in the gaming industry, in the gaming world. There are a few conferences that are really good. GDC and some of these conferences really good. This is one of them. It's Slush. It's held in Helsinki every fall, September, I think. And last year it was like 14,000 people that came to that conference, so it's huge. And it's also very good for startups, for introducing new concepts and so on. Last year, there was a lot of people from Iceland that went to Slush conference, so a lot of startups. And so this is very startup friendly. A lot of people, investors coming there and trying to find startups. So if you get around to create a startup in gaming, this is a conference you wanna. Slush Health is a conference you wanna pay attention to. Now we're having Slush in Reykjavik. This is the first time. The Icelandic gaming industry, IGI, is a member of Nordic game industry, which is the 5 Nordic countries in cooperation. And NGI, this Nordic Gaming Institute, decided to fund this conference in Reykjavik, and it's going to be 19th. I think these are not the final dates. We haven't. It has not been. So these are the dates that have been proposed. So it might change. I don't know. But for those of you who didn't recognize what's happening during this period or after on the weekend, nobody plays EVE Online here. This is FanFest, leading up to FanFest. So we are using FanFest to attract speakers, and the objective is to get speakers from America and Europe to get together in Iceland for a few days. And there are some limited seats in this. So this is a conference that is mostly invite only, but there are seats available for people. This is the price, and you'll get 50% off if you're a student or a startup. And this goes on sale 1st of February. So if this is something you would be interested in, you should check this out. Also, if you don't want to pay for anything, we are asking for volunteers that can help assist people and help in sort of small tasks that are needed to. All these conferences are complicated. There are lots of jobs that need to be done to make everything work. And so the conference is seeking volunteers. If you should be interested in being there with all these great game designers and people influential in the game industry, this is your chance to see what's going on. And just send me an email and tell me you would like to volunteer, and I will put you on a list, and you will be contacted by the conference. So a little bit of plug here in the beginning, but this is really good conference, really great speakers. So I think this is very useful. Okay. So now the main presentation today, Högni Vilhjálmsson, he's going to have a presentation on game engines. Now, Hannes, he is working here at the university. He's an associate professor at the School of Computer Science. He's also director of CATIA, Center for Artificial Intelligence, and something else. He might explain this. He's also been founding companies. He founded one company, Aloha. What's it called? Alelo. That was in the US and Mind Games. Mind Game was a really interesting game company, creating games that you can control by using your mind, brainwaves. Really cool stuff. So, Hannes, I'm going to just hand this over to you.
All right. Thank you very much. So, yes, so I'm here at Reykjavik University in the School of Computer Science, and I teach several courses related to game development. And this term, for example, I'm teaching a course called Game Engine Architecture. So it's actually sort of how you program game engines. So today I'm going to talk a little bit about what a game engine is. It's a very critical component of any game development. You don't have to always be a programmer to make a game, but you will probably all be using game engines, whether you're programming anything or not. So it's a very important piece that we should be aware of. And as Ola mentioned, I have been involved in some game industry things, but I'm mainly a researcher and an academic in the university world. But in industry, I have been using some game engines, and I'll talk about that a little bit later. One example of such a thing. So let's get started here and think about what a game engine is, really. It is some engineering behind it, obviously. It is some machinery. It is a very, very interesting piece of machinery. And for me, it's the way I think about it, it's a little bit like a magical box. It's kind of like this black box that sits somewhere on your system. And what does it take as input, and what does it produce? Any ideas? There's some kind of, yes. It takes as input some information about the user, what the user is doing, and so on, that's right. It maintains some kind of a state internally in some ways. It's also taking as input all of the art that you create. So in general, it takes in some kind of data. Some of the data is read maybe once in, like all the art assets. Some of the data is coming in as you play the game, as the user interaction. So basically, there's data being poured into this box. And on the other side, this is a great simplification, but on the other side, we get a game. So if you are making a game, you get one of these boxes, and you make data. And you pour the data into the box, and hopefully in the end, you will actually get an interactive game experience. And this is a kind of a nice simplified model, but this is really the idea behind game engines, that you produce something you can reuse again and again for different games. And the only thing you have to do is to change the data input, and you will get a different game. So that's the general idea. This is kind of in software engineering, it's a very good design methodology to build software that is capable of kind of supporting a number of different applications, a number of different games in this case. And you can think of all sorts of interesting variations on this. And just to mention one interesting piece is that some of these game engines, they come with tools, and these tools will allow you to produce data that's appropriate for the engine. So it brings you an editor or something like that, and the editor will help you save the data in a format that the engine will use. And some of them even come with special tools that optimize your data and crunch the data in some ways, and then presents that data to the game engine so that it can run really fast with your data, just as an example. So there's a little bit of kind of tool sets and things like that are associated with this line of data flowing into the engine. So that's the very, very top level idea here. So, and now we look think a little bit more about the game engine and what that data represents. What are we representing with this data? We are representing some kind of a world. So the data is describing a world in which some things happen, and these things happen to things we call game objects. So this is, again, a kind of a high-level idea of a game. You always have a world, and you always have game objects living in that world somehow. One way to characterize what happens then, what the engine is doing, is to call it a simulation, a simulator. It simulates a world. And what that really means, a simulation, is that it is able to tell you or simulate what happens when these game objects interact. And it will tell you, oh, okay, this game object, for example, collides with another game object, this will happen. So in that sense, you could make this thing simulate physics, for example. You could make it simulate anything you want. Maybe in one way, like you could say, the ideal game engine might not even be a simulation. It would just be real life, right? But we cannot make real life. We have to make some kind of a version of life. And as soon as we make these types of simplifications, it becomes a simulation instead of the real thing. So just the ability to simulate is one of these abilities that a game engine has. It's able to run a simulation. And it's able to make these objects that you insert into it interact. Okay. And you're not necessarily thinking about just like, a realistic environment. I'm also talking about completely like a cartoony environment or abstract environments. There's no requirement here about the simulation being realistic. I'm just saying for any game, even Pac-Man or those games, there is a world and there are interacting objects within it with its own simulation properties. So let's think a little bit about then what goes in as data here and how we might manipulate that data. So we typically, for game engines, we have to describe what the world is like. So game engines often supply you with tools that allows you to construct a world. Usually these tools are called scene editors or game editors or something like that, and you start a project and then you start a scene and you insert into the scene, okay, here's like the terrain and here's whatever is populating the environment. You build some kind of a framework around your world. And then once you have built the frame around it, you populate it with these game objects. And you will see that every game object that I have up here has two parts. And it's pretty much universal, this what I'm saying here. It has two parts. It has a higher part that's a bit gray, and then the darker part that is below. The first part of every game object here is what it looks like to the world. The kind of properties, how you describe that object. Does it look like a human or does it look like a brick? Things like that. And you can create the look for these things, usually in some tools like Photoshop, like tools like 3D modeling packages and so on. Those are called assets. So all of the assets speak to that upper part of the game objects. In general, these tools are called digital content creation tools, or DCCs. But this is not enough. It is not enough just to create that part of a game object. You also have to tell the engine, tell the simulation, what behavior does it have? How does it interact? What does happen when you collide with it, for example? And that part is called behavior in general, and is typically scripted in some language, programming language. It doesn't have to be a typical programming language. It can also be a dedicated scripting language for the game engine, some kind of a specialized language, or even a visual language, so you don't actually have to type any code. You just sort of select from a set of options what behavior you want. So these three things together, the scene building and then the building of the game objects, both the assets and the behaviors, that constitutes the data that you're pouring into the engine. And often, this is enough. You don't have to do more to make that game pop out of the other end. You don't have to dive into the internals of that black box. However, some cases, you want to change the actual underlying simulation. And this is particularly true if you want to build a new commercial game from scratch and you're not happy with how some of the game engines are dealing with things, or you feel like there's a missing kind of thing in the game engine and you want to get the source code of the game engine. And that's something you sometimes can do. You can get the source code behind this, you can change the source code, recompile it, and build your own magic box. And I'm putting this up here because you are faced with your own choice here. Are you going to stay up there? In which case you can take these engines that are out there and just use them. And you don't have to worry about whether you have access to this lower level or not. Or are you really interested in trying to get into the guts here and get the source code? In which case, sometimes you can get source code for free, but most often you have to pay to get this level of access to an engine. And I'll talk a little bit more about that later. But I think for the most part, you are not worrying about what happens inside here. So now I'm going to talk about some historical things that relate to this, this idea of separating game engines from the content that runs on the engine. So here is an example that some of you are familiar with. This is a game called Wolfenstein 3D, and it is often called the first-person shooter, kind of starting a certain craze with that type of gameplay. Came out in '92 by id Software, and for those of you that have not played it, because it's a piece of history, you can try it, and it now runs inside the browser. That's the game interface. Let's see if we can start a new game here. Which episode? Right. Oh, well, I'm not that. Well, they don't hurt me here. This is what it looks like, and I can now move around, open tools, look around here. Oh, I'm in a jail actually. Let's go here. Fancy. Oh, whoa. Wait, where's my... It's very, very gruesome. Very gruesome. Indeed. Okay, you can all try this game. It doesn't look like much, but it really did start a major phenomenon, because this was very realistic. I don't know what this looks like, but the illusion of being in a different three-dimensional space, being able to run around that space and interact with, well, although the interaction is quite limited to shooting them, you're still interacting with them sort of face-to-face. And id Software that produced this game was kind of throwing in all the tricks they could to make it feel like a real 3D environment, but it is really, when you think about it, you only run around in one plane, so it is actually more like a 2D game that gives you that particular illusion by raising everything up like that and placing you inside that two-dimensional world. But regardless of that, one of the things that happened when people got this game was that they realized that they could access the data that came with it. So when it came out, it was clear that id Software had followed that principle of here's our black box, and here's the data, all the assets for the game stored separately on the disk. And what happened? People started changing the data. So people hacked it in all kinds of different ways. They got access to the textures, and soon after this, you get things like that. Shooting Santa with, again, not a really nice thing to do, but in terms of game history, it was an important step. Everyone started changing the game in any different way that they wanted, just by changing the content. And instead of id Software coming out and saying, no, we don't want you to kill Santa in our game, they thought, okay, this is really, really interesting. Our next game will explicitly invite people to change the game. So the next game that they made literally said, okay, everyone, here's the data, here are the ways in which you can modify it, and let's see what you can make. And that was the creation of Doom, and the Doom engine. In 1993, they came out with this game here. And this is also a first-person shooter, and it's still kind of not full 3D. It's kind of again, an illusion of a 3D environment using still kind of these texture sprites to represent your enemies and things like that. But what is important is that id Software released this game with the explicit intent of allowing the community to then go in and change the game and make different content for it. And they call this now, at this point, like, okay, we have an engine. We constructed an engine, and here's this game that we made has this data. And they continue then to support the community with new engines and new ideas for doing first-person shooters. And this is a very kind of a nice, that id Software has always played very well with the community in this sense. In fact, right now, many of these old game engines that id Software made, they have made full source code available to everyone for free. So if you're interested in actually how they did this, how they programmed these engines, the full programs and source code are out on the web, and it is really pushing it out there as a way to learn about these things. Anyway, Doom came out in 93, id Software came out with Quake in 96, using another iteration of their game engine technology. And most notably in Quake, they went full 3D. Finally, you have fully 3D realized environments. But again, like any of the predecessors and then pretty much in game development, there are always tricks everywhere. And one of the interesting tricks that it was doing here, you can see how well lit this is. You can't quite, if I just quickly take off the lights and bring it back up, you'll see how the shadows of the environments bring out that realistic feel of depth. Here. Well, id Software decided to use some tricks here to make this realistic. And one of the tricks that they did was that, you remember that picture that I showed in the beginning? This picture. id Software added some tools to produce data in a certain way. So you describe the world, and you send that description into the Quake engine. What they do is to look at your data and then do some kind of simulation of lights with your data, meaning that that light will affect that object in this way, and the light will affect the other object in that other way. It did that before running the game, and then stored the results of that lighting calculation, and then store that as textures that you can wrap the objects in. You don't have to do this yourself. It basically just creates a lit texture for your objects and sends the lit textures back into this data stream. So the textures that in the end are being run by the game engine are already embedded with information about light and shadow. And so it's just one example of, and this is called light mapping. So the Quake engine had that tool that does light mapping for you, paints all the textures with lights, and then stores those textures and then puts it into the engine again for something as realistic as this to happen. It also had some dynamic lights. So it is using a combination of light maps that are painted on the walls and also dynamic lights that can move around the walls. The reason why they could do also this dynamic lighting and some of the nice 3D effects, this is one of the first games in the world that used 3D acceleration. We take this for granted today, that your machine, your PC or whatever, has a dedicated graphics card in it, that you have a 3D acceleration unit inside the machine. Back in those days, that was a novelty, and those things did not exist everywhere. When they built this engine, they decided that they would make use of this acceleration properties, and so they could do amazing things with this engine. So this is 96, this generation of kind of ID or IT technology engine, and then they continue. I'll just quickly go through the 99. They came out with Quake 3 Arena, which is a multiplayer game, kind of an arena shooter. There was a lot of emphasis here on supporting seamless, fluid multiplayer games, and they did some improvements of animation and the networking code and all that stuff. If you're into programming, these engines were all written in a language called C, a very, very kind of hardcore, low-level language. Finally, when they go up to 2004 with kind of the Doom 3, there was a game called Doom 3, if you remember, it used the id-Tech 4 engine. This game engine was written in a different language called C++, which is an interesting language for building software that is a little bit more high level, you could say, than C. So the source code is getting a little more readable at this point, say. But notice here that the visual realism is going up. Every time id Software releases a game engine, their simulation is improving. Their simulation of the world is improving in realism. And thanks to their kind of having the fingers on the pulse of technology. In fact, they are inventing a lot of new technology to make this happen. And here in this version of the engine, they support what is called shader programming. So you as a content, like basically a content creator, you can program how objects interact with lights in the scene. And they allow you to do this through support of shaders. And then id-Tech 5 was behind the game called Rage. And here they're going like totally crazy with detail, especially in the textures. So they're allowing you to bring in assets that describe game objects in incredible detail. The textures that are painted on the objects in this screenshot, for example, the textures themselves are, well, you could say probably in the order of gigabytes rather than megabytes. I mean, a single game in this engine can take an enormous amount of space. Game objects can take an enormous amount of space, and they sort of perfected a way to compress large textures and apply them at runtime using certain techniques. So id Software has been going from Doom and all the way to Rage and onwards with their game engine technology. Every time they put out a new engine, they also put out a game to show off the technology in some ways. But every step of the way, other people like yourselves or other developers, they can use their engine. And you can see all sorts of games using these engines. id Software was very important in all of this kind of developing the technology of the engine, but other developers were also important. And here's one developer, Valve Software. Valve Software is responsible for the Half-Life games and Portal and so on, you are familiar with perhaps. An interesting thing is that the original Half-Life was actually running on a modified version of the Quake Quake engine. So they were using Quake code to build the first Half-Life. And but they substantially changed the source code on the way. So the further you go along, it's kind of more and more separate and different from the original Quake. They released Half-Life in '98, and they continued to improve their version of the engine. And the improved version continued and became the engine behind Half-Life 2. And you can see that this is happening sort of in the same time as Doom 3 up there. And both of these engines were supporting shaders and this kind of realistic lighting calculations that I mentioned briefly. If you're in, the Valve called sort of the original engine, they called it Gold Source, and they called this engine Source. And you may appreciate or not the story behind that, which is basically they were developing the source code for this engine in one branch of their version control system. And then when they had a stable version, they added the name Gold in front of it. So, okay, that's the stable version of our source code, and let's branch it off and release a game. But the source branch kept going. So they called it everything source at the beginning. At some point, so that's a Gold version, let's put it aside. That became Half-Life 1, the source kept going. At some point they had Half-Life 2, they didn't bother changing the name of it in a way, so that was called Source. So we have Gold Source and Source as two separate versions of the Valve engine. You can work with these engines today, if you like, and again, many other developers have used the Source engine behind the games. A third developer that was important in this history of first-person shooter games in particular is Unreal, basically Epic Software. Epic Software released a game called Unreal in '98. This is ancient history, everything. But these guys immediately wanted to make something that was very easily edited and modded. And they released editors for their game environments, and they made the source code also very readable and easy to use. So they were making life very easy for them at the very beginning, and therefore became very popular as an engine for other people to use. It was quite easy to get up and running with this engine. They themselves developed the engine called the Unreal Engine, further with several different games that they released throughout the years. The Unreal Engine 2 came out around this time, and of course it supported some of the Unreal Tournament games when they came out. Unreal Tournament is a multiplayer game, so they had a lot of nice multiplayer networking code in there. But actually the first game to be released with the Unreal 2 engine was the American Army game. Anyone familiar with the American Army game, just out of curiosity? Yeah, so several of you have actually played it. And it's an interesting game because it was released by the US government just to have people understand and see how the America's Army works, how it actually works. And in some ways, it's also used as a recruiting tool. So if you're interested in the Army, play this game and see if you're still interested, and then they will actually take you through some training in it. And then it's kind of an interesting concept. They could also kind of track who is good at it. And you kind of get the feeling, okay, they will contact you. Well, maybe it's not just a feeling. They will actually contact you if they're really good at this game and try to get you into the Army. And then you have later technology, Unreal Engine 2. Again, the realism is going way out of the charts here with new engines. And we're up to Unreal Engine 4 right now. And again, the realism is being pushed. So these are three strands of first-person shooter engines that are very popular and kind of have defined this whole field of game engines. There are other game engines that exist, and you're probably familiar with some of these already. CRYENGINE was also a very powerful engine from Crytek, and has been powering their games like Far Cry and Crysis, those two series. But they also allow third-party developers to license their engine for whatever they want. Then we have the Gameplay engine. This is the engine that has been used in the Morrowind series, like Oblivion, and not Skyrim though. I think they have kind of changed it there. But at least Oblivion, and the previous ones, as well as Fallout series, Fallout 3, I should say. So this engine has been handling quite large worlds. So it's the same way as the CRYENGINE they have been doing. So maybe you could say that the first, all of these here, they initially all took you into confined spaces in a way, and relied on that fact, although they have been slowly opening up into much larger worlds. With the CRYENGINE and the Gameplay engine, they're really trying to open it up to large vistas. And then you have the Frostbite engine, which has been used, this is from DICE software, and that is basically like the Battlefield games. They've also been pushing this outdoor environments. And then you have Unity 3D up here at the top. So these are some examples of the other game engines out there. And they've all been constructed in this way of, here's the box, and now give me the content and I will simulate the game objects and make it real. Now, how do you work with game engines? And I'm going to give you a few examples of what you can do when you have a game engine or a game. And one way in which you can play with it is to just modify a few things in the data that comes with an existing game. So you buy a game and there's some kind of an editor with it that allows you, for example, to change some parameters in the game, change some textures, do a little bit of fiddling with the existing content, if you will. And that's what usually is called a mod. So you're modding an existing game. Maybe by adding some details, like you can find a lot of mods for games like Skyrim where people are just updating the textures. So they're taking an existing game and improving it in some way, or changing a little bit. And here someone added the whole galaxy to the sky. Someone is maybe using the content that are already there for a game and building a new story into the game. So here's someone taking Portal and then creating a little bit of a prelude story in that same game world, but not changing very much in terms of the content, really just using the existing content that comes with the game. Those are game mods, just a couple of examples. Then you have something called a total conversion mod. A total conversion mod, the aim is typically to almost erase the traces of the old game and replace all of the assets, all of the textures, all of the sounds, or as much as you can to make you feel like you are playing a different game. But still, it's only at the content level, only at the level of changing the assets. And just as an example of that, here is a total conversion mod for the original Doom engine that took the game Doom and made it into a Star Wars game. And so I'm just going to give you that quick example. Maybe I should have shown you first maybe how many of you have seen the original Doom? The original. Well, you've seen the original Doom. So I will just play the modified version then, which is this little video clip here. This is Doom Star Wars. Still Doom, pretty much. If you actually play this a little bit, you realize you are playing within the blueprint of, I think, the Death Star. I mean, you actually see the direct mapping onto the film itself, the original film. And so whoever made this took really good care of building the movie set with their own textures, with sounds. Okay, this is totally not good use of copyright material because they're probably taking this from the movie itself, the sounds. So they should really be careful with that. But they're trying to recreate the experience of the movies. And they're literally just using the Doom engine as it was without any changes and just switching out assets. So they create a whole new experience. And here I have an example. I actually don't have a video for this, unfortunately, but this is one of the games that I was involved in. And Ola mentioned that I founded a company in the US called Alelo that does simulation games for social simulation and training. And our original project was to make a game that would teach Arabic. And we wanted to have a realistic game world. We wanted things to look really good and play really well. So we took a good game engine, and at the time that was the Unreal Engine. We took the Unreal Engine and we modded it, but we totally modded it. We changed a lot of most of the assets and things like that. And we turned Unreal Tournament, which is an alien shooter multiplayer game, into a social simulation game. So here you walk around the streets of Iraq and you interact with the locals, but instead of shooting them, you actually talk to them. And you have to be incorporated speech recognition. So you have to speak to the people and they're in Arabic and they respond to you in turn in Arabic. And that way you're solving all sorts of tasks in this world. So it's pretty much unrecognizable from the original Unreal Tournament. I have kind of fun telling you about one thing though that was not properly replaced in our total conversion. One of our early play tests of this environment, which you cannot actually kill anyone. If you have to reach for your gun, that means you lost because it's all about making sure you use social interaction to resolve any conflict. But anyways, in our early play test, then we found everyone dead in the environment. And we were really wondering how can that be, because we took out all the weapons, all the Unreal Tournament weapons, and replaced it with a microphone. But we found out that some of the people that were testing it realized that we still had the jump function in there. And they were able to climb on top of the different furnitures and then jump on the heads of the local Iraqi people. It's really awful to do, but they killed everyone that way. So even if we were, thought we were doing a total conversion, still some of the old functionality was obviously in there, and which is kind of a bad result. So those are total conversion mods, and some classic total conversion mods have later been turned into full commercial games because they were so successful. And here are some of the total conversions. Here is the Defense of the Ancients, which was a total conversion of Warcraft 3, and this then became kind of this whole genre of lane pushing games. The Dota is now a standalone game based on this original mod. You have Team Fortress, which was a mod of Quake, and now that's a standalone game. Call of Duty was the Quake 3 mod. Dear Esther was kind of a narrative experience built using the Source engine, but then became a standalone game. And Stanley Parable also on Source engine, that's also a standalone game. So if you want to get into the game business, one way to do it is to make one of these major mods and get noticed, and then someone will say, okay, that's very commercially viable, let's make an actual game out of it. And what happens when you do that and you make a standalone game, you no longer have to do a mod, you can get access to the full source code and then maybe release it as such. And that's what we did here. We started as a total mod, and then later on the company acquired the source license for the Unreal Engine, and we got rid of like all the all of the artifacts that was still sitting in there. Total conversion mods. Here's a couple of, here's one total conversion mod that I'm really fond of because it completely changed the game from the original game. The original game was Half-Life 2, and they turned it into this. And I just have to show you what it looks like. Here is a video clip from a mod of Half-Life. The fun 2D world where you can flip between the light side and the dark side. So you are happy and everything is wonderful on the bright side, but in some cases you cannot overcome an obstacle without becoming really bad. So you flip into the bad side and do something awful, come back to the bright side, and things go on as they were like perfectly nice. So it's, if you're interested in game design and especially kind of the artistic side of things, then this is a very nice thing to look at. And it's an incredible example of something where you take an existing 3D world game engine, turn it into a 2D game. Now, so that's total conversion. You can also, of course, use game engines that don't come with any content to begin with. It's just a game engine, and it tells you, okay, just do whatever you want with me as a game engine, make your own content, and I will help you run it. An example of course game engines that do that is the Unity engine. It is not tied to any particular game. You just get the Unity engine and you start working with it, you build your own content, and so you can build your own games from scratch. I like this example here of the game You're Being Hunted, which is built in the Unity engine. Just as an example of a game that has been sort of successful, at least gotten some attention. And then you have other game engines for other types of games, of course. And Adventure Game Studio is just one of them, as an example. And then when you want to get a full source license, you also get some interesting games popping out. And this is where you go inside the box and change the source code, make the game engine do things it was not made for to begin with. And a couple of my favorites here these are pretty old examples, still favorites. So the Quake engine was modified at the source code level to support this game called America's Mikey Alice. And if you're interested in level construction and kind of artistic presentation of 3D games, I recommend looking at this particular game, which turned Quake into quite a surreal experience. And then we have the Deus Ex series that you may be familiar with today. It really started as a modification on the underlying Unreal Engine. So they kind of make their own engine using the Unreal Engine as a base. So that's all of so now I've counted the different ways in which you can make a game using an engine. Starting with the game mods, very lightweight, top level, replace a few textures and such. Total conversion, replace everything, put your own stuff on it, make it look different. And then you have toolkits you can build on top of from scratch. And then you can get actual engines. This is the most work, where you actually have the source code and have to change the engine itself. And now I'm thinking, should we take a break at this point, maybe? So we're basically an hour, 15 minutes in. And what I want to do is to walk through a couple of examples of using game engines. I think go ahead.
Some questions. Should I wait for the
Oh, sure. If let's say we have now, okay, why don't we take a few questions, and then I want to have like a 5-minute break just to stretch our legs, and then go through a couple of game engines. These 3 game engines I'm going to show you a little bit about. But let's end then with a few questions if you have. Yes, please.
You said in Wolfenstein, the game had a feel of 3D, but the book of the game is in 2D.
Yeah.
And then later, I think you were talking about Quake.
Yeah.
And you used the term full 3D.
Full 3D, that's right.
So what does it make a game full 3D?
So yeah, good question. What makes a game a full 3D versus like sort of simulated 3D or just 2D? So in this case, there are maybe 2 things that we are considering. One is that immediately what you will realize is that you can look up. In Wolfenstein, you could not look up. In fact, in Doom, you could not even look up either. So it's always facing this way. And another thing you will notice is that you never cross a path above where you were before. So when you're moving around, you always stay kind of in a 2-dimensional world in a way. Even if you go up, you never cross. So you can go up steps here, but you never find a bridge.
There is a room I played, I don't remember if it was 1 or 2, that sometimes the enemies come in along the platform.
Yeah.
You cannot pass above, but they can be below. You don't even have to aim down. The bullet will automatically go down if it's on the horizon.
Right, exactly.
That still doesn't make it 3D, right?
Well, that one sounds like a 2D thing. If you're basically just able to aim in the general direction, and it will hit them at whatever level it is. So they're doing collision just in 2D, basically. In the Quake world, those constraints were all taken away, and you can just be inside that 3D structure, any 3D structure that you wanted. Yeah.
Just want to add that you noted that in the 2D games you can't go over.
Yes, exactly.
There are tricks.
Oh,
Remember
yes.
that Bungie did that with the Marathon engine, at least, where they nicknamed it, I think, 5 dimension or something.
Oh, I
So
see.
you could actually have an area that overlaps another area, even go through it.
Yeah.
You could make some really interesting tricks with that, so real tricks.
Yes, that's right.
But it was still a 2-dimensional game, even though you had staircases and everything.
I'm glad you mentioned Marathon because, I mean, my platform has been the PC from the kind of beginning, but the Macintosh actually had some pretty amazing technology also back in the day. And Marathon is one of those shooters.
It was the doom of Macintosh.
Yes, the doom of Macintosh. So if you're a Mac fan, make sure you look that one up. And it's the things that they were doing there.
And the ancient behind it, Marathon 3, is called LF1 and is open source now.
Excellent.
And that was the ancient that sort of got me into.
Well, very good.
In the past.
I should probably also mention that Unity 3D was built on a Macintosh. It was basically a Mac engine to begin with. But they immediately, when they started developing Unity engine, their kind of selling point was the cross-platform kind of compilation of different games. So they quickly were able to support the PC and other platforms. But you can see that they're kind of rooted a little bit in the Mac world. They always looked at the interface as the primary thing to get right in some ways, and they have kind of been able to stand by that ever since. Any other questions about what I've gone over so far? Yeah.
So, for instance, Warcraft 3 is a 2D game.
No, actually, Warcraft 3 was a 3D game. They actually built it as a 3D engine. But they constrain the player input and the player control sort of in a certain way to make it the interaction easy. So they're not necessarily allowing you to fly in all 3 dimensions, although I think you can actually.
There is a thing about that. You can be working on even the right.
Yeah, yeah.
You can notice you're looking from above, like the look height. You can spin the camera like this, like this.
Yeah.
But your interaction with the other objects seems to be in 2D. Even if you are shooting in diagonal to them, it doesn't affect anything in the mechanics of the game.
So I mean, so in that case, the mechanics of the game are kind of separate from the engine. The engine is 3D, full 3D, and the mechanics of the game can be tailored to kind of just work well in terms of what is a good gameplay. And for them, they have made the decision here, let's just keep it that way, keep it somewhat simple in a way, so that every action is going to have a clear reaction and things like that. They might also want to prevent you from creating enclosed spaces so you don't lose your units inside the cave or something like that. But this engine will support a cave, I'm pretty sure. So those are maybe 2 different aspects of the game. It's the game mechanics and the gameplay and the engine itself.
There's also another game I played. It's called Magic Graphic.
Right.
You know the game?
Yes.
It's very old. I think I played like in 1995.
Yeah.
And that game, though the graphics are very old, you can move in any direction.
Yes.
There, you can shoot.
Absolutely. Yeah, there were some pretty amazing experiments with the 3D world and how do you render the 3D worlds. I think that one may have used voxel graphics even. Voxel graphics. Maybe a little bit different representation of how they store the data about height in the environment, for example. But that's an interesting venture into the 3D world. Let's take just 5 minutes. So just past 2 o'clock, I will show a little bit of examples, but it's just stretch a bit and maybe get water or something. I guess the coffee should was off. You want to pause this?
Ja, det såg man. Ja,
Wow.
skóla.
Ég er mikið að smitist í þessu gegnum á myndleiknum. Eins og þú talar að fyrirleik, það helst alltaf að horfa á hausinn. Ég veit að líka þannig með svona kveik, og þá það svona galt í kveikan sem það streifað og það karjast yfir í þessum kollektífi líka.
Ég meina, en ég hefði haldið að þeir sem voru að búa þeir myndi geta komið í veg fyrir það. Kannski er það líka bara að þegar leikmenn eru vanir ástæðum ákveðin en ákveðin. Bara til þess að gera það ekki frustrerað.
Þetta er samt, þetta er svo edskjörst, þetta er ekki venjulegt að streifa til hliðar, þetta er sko hoppa, það farið acceleration á því að beigja á haldinni.
Ok, það er bara svona, já, þá er það bara lítið sem já, ég meina, það er svo oft til þess að koma í veg fyrir það að þá fast þig að fara aðeins líka. Já, bara aðþingi og bara tekka þetta, hvað er þetta, exploitation.
Já, ég er svo gaman ég byrjaði eitthvað út í henni.
Já, ok.
Svo fór ég yfir í kveik og það var það sama, nákvæmlega eins. Svo kom það að hvernig hluti var renna á sama henni.
Nákvæmlega, það er akkurat þannig. Já, ég held að það sé eitthvað í alveg.
What looks like beyond is actually what's supposed to be that organization step it's not a difference. On the same for basically boxes basically there's no other dimension. It's also there and get
Já, sko, ok, þú þeir eru með alltaf svona primitífa og hluti sem eru kannski með langur eins og þetta. En við erum bótt í að nota 3D Max eða það er einhverjum basic hlutarna. Þeir eru með svona template linki líka. Þú að skrifta frá ég gæti ekki sett það upp á þessa en ég verði að skipa ég þetta en ég var slett að sýta aðeins
the store is aligned, so now the geometry is second. So I did that. So that's
Pero sobre el
so I getting that into very old path to do interesting things. Took a lot of just instead of using this as a teaching tool, but like the students. It's like having two different views on the same space. They actually do it in the space. And then like you push a button to do like there, some kind of shape.
I love it. Really, guys?
That's usually the end of doing still see
Ja. Ja, okay. Yeah. I saw it on Nee, maar afspelen, dat is niet ja, ja, maar dat is wel mee. En ook als ik elk wel eens bij mij. Okay, so let's get started again. And I pick three examples of game engines: the CRYENGINE, the Unity, and Construct, and they kind of represent sort of somewhat different approaches to things. I wanted to also show the Unreal Engine, but I'm actually running on a very old. I think this machine I have here with me is like 7 years old, something like that. So it's an ancient machine. I'm still able to run these game engines, but for the latest Unreal, I'm not really able to do it justice. So I'll leave that out for now, but you'll still see some nice things. And the CRYENGINE is basically, the engine from Crytek that I mentioned earlier. And this is an example of an engine, one of the earlier engines that really allows you to run the engine and edit and interact with all of the content while the engine is running. So you are literally inside the world, and you can change the world and change the content from that perspective. The Unreal Engine was also one of the earlier ones that allowed you to do this. The editor and the game itself was kind of integrated this way. And what is really nice about it, you can learn a lot about games using editors like this. Just to let you know how you get this engine, because if you go to the CRYENGINE homepage, you actually directed into the paid version of the engine. But if you really just want to experiment with something and you're not intending to release a game with it just yet, if you just want to do a little bit of what you could say non-commercial use, you can go into the community and look for downloads, and here you get a free SDK and for non-commercial use only. And this is enough to maybe kind of play around with it, and you can download this. And once you download it, you will get this this environment here. It comes with content for some demo game levels, but it's not tied to any particular commercial game yet. So this is what is called, I think, the island or something like that, forest or something, that particular level. What you're looking at here, I'll fly out a little bit, is a simulation that is already running. The editor points out all of the game objects. Remember we were talking about the game objects existing within the simulation? Well, you can literally see the game objects with these little icons here. And with any of these objects that you see in the world, you can go in and, well, you can edit them, you can bring up their properties, change them. You can move around, and I don't know if you can make some example here. That's one of the birds that is moving around. Some insects or frogs or something. You can interact with any of these things and change its properties, and therefore maybe its appearance or behavior. And at any point, you can go and say, I want to switch to the game itself. So you press this one button, and now you're inside the player. It actually spawns the player where you are at that moment. And the game mechanics that you have scripted or made available, they are now running. So you are experiencing your game world exactly as the game would be running. And then you can jump back and forth. You can just create. What did we see here?
The frog disappeared.
Oh, the frog. The frog?
It just vanished.
It vanished. Ah. There's the frog. Let's not see it. Oh, it's an elephant. So you can decide to take any of these objects, like that block, put it somewhere else. I don't know what happens to do there. Well, it's still there. And here we're just going down. You can see all the different objects that are there. It's nice to have a level like this that has already very nice natural things in it. But what happens if you want to make your own from scratch? So let's just do a new here. And let's just say, game creator test. And nah, I'm not going to save that one. So what happens when you start a new project? I'm just using the defaults everywhere. I'm not concerned yet about anything. So when you start a new project, this is what you get. You get the ocean. So it's almost like now you are God and you have to create the world from scratch. And how do you create a new world? Well, this you can see how this game engine was originally used to create Far Cry and those series. They're always islands. I mean, the worlds are always islands. And here, let's just quickly create an island. And you use the terrain tool to do that. You edit a terrain, and you generate it. Let's first decide that we are what the height of our island is gonna be. So we'll set the maximum height to kind of a lower value than the default one. And then we'll generate the terrain. I'm just using the default everywhere. And terrain in game engines is usually represented by a two-dimensional image. And it's a grayscale image, meaning that it has only gray values, black, white, and everything between. And this is called a height map. And black is the lowest value. It is basically 0. And white is the highest value, which is 1. And that is used to represent the height of the island in different points. So down here we have low areas, and where the white spots are, that's the high areas. And it uses a certain algorithm to generate these smooth transitions from low to high. So that our generation pattern here is actually kind of smart in how it in a random fashion generates this height map. And we can further modify it by making an island that kind of cuts it and shrinks it a little bit to make it look like an island like that. So now we have a height map for an island world. And we just have to say, okay, that's the one we want. So we're done here. I think we're just done. And if we back up, I hope that we will actually see our creation. Yeah, there it is. So this is our island right here. And that's all there is to it to get started, really. Now you have your level, and you can fly into it, and you can drop down into it, and you can start playing in this level. It's not a very interesting level, but you can go down to the shore here somewhere, and you can. I hope I don't die, which okay. Whoosh! I died. It was too high of a fall, actually. So if I really want to make sure I don't die, I have to start down here, I think. Okay, I'm down here. This is my desert island. There's absolutely nothing there. And then if you want to start making it look a little bit more interesting, you have to, of course, apply some materials and texture onto this, but you're just working with data. That's all you're doing, really. We can, let's say here. Terrain, textures, we have to pick some textures for this. Find There's so many folders, there's so much content that comes with it. And then we kind of lose track a little bit about where those things are. We'll just go back here and just get something. Okay, here, I'll just get this here. So basically what I was doing right now was that I was defining one type of a surface that is used to paint terrain. And for any kind of terrain surface in this engine, there are two parts to the surface. One part is what you see really far away. Kind of gives you a general feeling of, okay, there are some differences between that area and that area. But then when you zoom in and get really close and you literally stand on the environment, you want to see a different appearance. You want to see individual grass, like little pieces of grass or rocks or whatever. So there's a detailed material and there's a far away material. And that's what you're selecting here. You're selecting the detail up here and then a layer texture for the distant version. If you then paint that onto the layer, onto the level, you can kind of use this brush to do it. Oops, okay, I don't like, I probably should select a grass color to it. Green. And I didn't name it anything. Now I've named this thing that I created. I created a couple of, I put a couple of textures into this layer here, call it grass. So when I go into the layer painter, I should now see grass in my selection of materials, and I can make that one green with the color picker. And now if I paint it, you can see it's green. I can make it my brush really big. And I can make all of my island green using that material. Okay. Now if I go back in here, okay, I didn't select the detail texture properly, but let's just go in here anyway. So now I'm walking around on a green surface, but with an interesting detail texture. I can also add some vegetation here. Whoa. Yeah. Okay. Oh, those are kind of funny, these trees. And oh, I got hurt there. But you sort of get the idea here. To actually do these things, it's of course easiest to find tutorials for the different engines to try things out. But here, it is still the general principle that you are adding game objects and setting properties. That's all you do all the time, essentially. And there might be different ways in which the engines kind of group together content. And in this particular case, for example, the vegetation is in some kind of a vegetation group that I created. I called the vegetation group forest. And within the forest, I placed many different game objects that represent the different aspects of the forest. And then I can essentially paint the world with the forest objects. And this game engine allows you to put this into a brush, essentially. You can paint game objects onto the surface. in a very nice interactive fashion. So yeah, I'm not making that ridiculously nice looking level that you saw at the beginning, but you can get up and running quite fast, especially if you're following these first steps. You first create the island, and then you made it, so create a look for the island. I'm gonna jump into a different engine just now. Let me show you Unity for a minute. Probably, maybe most of you have been using Unity, so I probably not be telling you anything new. But it's interesting just to think about this separation again between the game engine and the data, and also this concept of the data or the game objects, both constituting of some kind of properties and also behavior. And so here, this is Unity, and just to get something really quick going here. So Unity organizes your work in these different areas of the screen, and this up here, this window up here, represents the description of the entire world or scene. This is your scene description. Within the scenes, you want game objects that interact with each other. So you kind of drag game objects and throw them into that scene up there. The game objects, like I said earlier, are constructed from some maybe information about appearance and also about behavior. Those things can all be stored in your assets folders that you have on your hard disk. So you can find these assets and you throw them into your game environment, and they become game objects that you can interact with or use in your scripts. Right now, there's only one game object in my scene, which is the main camera, but I'm going to add game objects. You can also use these menus to create new game objects from kind of standard game object types that Unity supports. So I'm going to just throw in a couple of them, including here plane. So this is just a two-dimensional plane that I'm going to throw in there, and then throw in a sphere. So let me put the plane, and the sphere is over there. Oh. And as you select the different objects that you are placing in the scene, you get their properties on the right-hand side. And these properties are then used when the simulation is run, when the game engine runs. Then the simulation is going to check these properties and run those scripts as you have told it to do. If the game engine is doing things properly, everything will work. So now I have these two objects. I have the plane and I have the sphere. And the properties, I can add more properties and behaviors. And one of the behaviors of objects that we might want to simulate are physical properties. And Unity comes with already built in some behavioral properties that you can just kind of drag and drop into your objects. And so I'm going to add a component to that sphere for the physics. And I'm going to add the rigid body component to that sphere. So it adds more information on that side, it adds certain behavior, and when the game engine runs, it speaks to the sphere and says, how do you want to behave now? And the sphere already has physics behavior now associated with it, so it responds with, well, I am a physics object. I want me to follow the laws of physics, and the game engine will make it so. I'm also going to give it a little bit of properties of a bouncing ball. And so I have an asset here that describes the bounciness of a sphere, and I'll associate that with the collision component of that sphere. So now when I run the engine, you actually see the ball. Oh, it was a sphere to begin with, but with that physical property and behavior associated with it, you now feel like it's a proper ball. It's a bit dark in here, so you can add another game object for lighting. You just put a directional light in here. This will light all the game objects. The light will interact with all the game objects. That in turn will tell the game engine, you know, this is how I look. And then if you want to get really fancy here, let's see. You can make the light cast shadows. And so now things are all of a sudden looking realistic. This is really interesting that in a few clicks, essentially, I go from nothing, like no world, into creating an illusion. It's a complete illusion that we have a ball in a world that follows both the laws of physics and the laws of light and shadow. I did not have to program the behavior of the light. I did not have to program the behavior of physics. Those were given to us as little components of this engine. And so you can sometimes think about it, like, what kinds of components does the engine give you? And Unity has a lot of different nice components. So light and physics are already a part of this. It is not interactive very much at the moment. If you want to start doing interactions, right now the world contains these objects. One of them is the camera. So when you press play, it will find the camera and simply stick you in here, inside the camera, that you have camera object. And there's no way to move around or anything like that. But Unity also provides you with a camera that is attached to the keyboard. So you can actually move that camera around and you can have it represent some kind of a player. So they have put together all the objects that are required to simulate a first-person shooter type of a game. And they have carefully saved that out as kind of a combined asset that you can drag into your project. It's called the first-person controller here. You drag it in here into your scene, and by default it places itself in a weird location, but you can kind of put it somewhere nicely. There you go. So, and then I take out the default camera. So now we have a first-person controller, we have the light, we have the plane, and we have the sphere. And you can try this. So now I'm actually in the world. Unfortunately, by default, the first-person controller does not really have any kind of physics associated with it. But if you want to start interacting with the world, the one kind of neat little trick would be to allow us to hold the little object that has physics. So if we make a little cube and we move the cube into the first-person controller, that cube is now going to be attached to me as I move around. So here's the little sphere, and maybe we can make it a little bit smaller. So this, okay, it's a little bit to the side, so maybe I should align it up with my camera. So here's the first-person controller, and the camera is looking that way, and the cube should be maybe here in front of me. Maybe I'll take the ball so we can move the ball a little bit in front also, so I can see the ball here. So there's the ball, and there's my cube. You can see I'm carrying the cube around as I move around. The cube just intersects like that because it's not yet a rigid body, does not have a physics simulation attached to it. But I can do the same thing I did with the sphere, that I can select my cube and then add the physics behavior to it. that. And I'm going to make it really heavy, which is one of the properties that come with that particular rigid body component. And let's see if I still have my cube. Oh, okay. It is the physics simulator. I think I bounced it on the floor. Ah. Okay, nice. I'll look at it from the side. Oh, it's following gravity. That's right. Yeah.
There's a checkbox.
I can take maybe gravity off the cube. Okay, now I have it in front of me, and a little bit high up maybe. Put it. And now I can still. Okay, physics are tricky. Let's get all the power. We can see now that I have a player in here, and I'm carrying something, and I can, if I'm very careful, push the ball. And the cube also goes a little crazy. You can already see an interesting game developing here. Like stay on the plane and not lose your ball and box. But in a few clicks, I'm setting up a simulation. And the simulation again is the core of the game engine. Provides the platform on which the simulation runs, and you just feed it with objects and you feed it with behaviors. And often these game engines come with behaviors already packaged. You drag them and drop them into the game world, and then things start happening. I'll stop here. I'll stop here with Unity for now. And the last one I wanted to show you, just to show you something completely different, is a 2D game engine. And so we have Construct 2 is just an example of a game engine that you can download for free, at least to a certain extent. You can use the free edition. You can pay if you want some of the advanced features. But this is an example of an engine where you don't really need to program a lot yourself. It basically uses kind of concepts from visual programming to describe behavior objects. I'm just quickly going to go through a simple example, and you can also go through these examples yourself using the tutorials that are there. So I'm just going to go through the first intro tutorial for this game engine. So we are starting a new project here. This is a new project, and that's the world, basically the scene that we are working with. And I'm gonna change the size of the scene. That's the layout of the entire game world. And most of the things in this game engine are just point and click. So you want to change some of the properties of the things in front of you. You pretty much just point your mouse at it and click, double click in this case. And here we want to get a tiled background on our main layer here, and the layout. So you get a tiled background, and you want to insert that one. You want to insert it onto this object. And now we can load an image from a file, and we have a tileable texture available, and that is going to then get associated with this world. Oh, this was a tile background, and we want this to fill the full size of our layout. So we'll start at 0, 0, and we'll go to the size of the full layout here. That's how much we want to spread it out basically throughout the entire layer. So that's just a property. So now we have a whole game world. It's a small game world, but it already exists. And we want to drag in some game objects that we want to have interacting inside this game world. And Construct makes it incredibly easy to make game objects. In fact, if you have the assets to the game objects, it actually allows you to do this. Okay, it's a bit narrow here. If you have the assets, these are the assets. There's some graphical textures. You just drag the texture and drop it onto your game world. So here, it dragged the image of this player character and automatically created a game object called a sprite. And a sprite is kind of like an interactive graphics inside the game world. And this is a proper game object now. It's not just a texture. It actually comes as a proper game object once you have dropped it in. And we can have monsters in here. We can have other things like bullets and explosions in the game world. And they now all exist within our game itself. So we have this guy. We also want to okay. Oh shoot! I forgot one thing. So what I just did now is that I put all of the game objects into what is called the same layer. So the background and the game objects are now all inside the same layer of the world, and that's kind of makes things a little bit more difficult. So what I'm going to do is that once I did my background here, I'm going to call that layer the background. And I'm going to add a new layer. I'm going to lock the background, so I'm not going to mess with the background. I'm not going to mess with the world anymore. I'm going to add another layer on top. And that layer is where I'm going to place all my objects. And I'm going to rename that as my main layer. And then again, I can take the objects and put them on top of the main layer. And here we go. And with this guy here, this sprite, I now know what it looks like, but what is it going to behave like? I can go into behaviors that are associated with this sprite. Let's actually give him a name that also makes sense. I'll just call this the player. Already taken? I guess when I deleted it, then it's annoying. Oh, because I made them all before. Wonderful. Layer 2. That's it. I'll take them out here. So the original ones I'll take out. Here. Now I should be able to give this the name player. And then this one, the name monster. This one is explosion. And then this one is bullets. Just like that. And I can add some behavior to this. And I can press the behavior property of my player character. I can add a new behavior, and I can, for example, add an 8-directional movement to my player, like that. And I can also select it, and I can add another behavior that makes it bound to the layout, meaning that it will not allow me to exit the world. Might be important. So now I'm stuck to the world if I add this behavior. And for any of the, you can notice that as I add behaviors, each behavior here in the editor here has properties. So the 8-directional movement has a speed property, and I can change that down to, let's say, 80. It's slower thing. I can add behaviors to the monster also. And I'll add the bullet behavior to the monster. In this game engine, a bullet behavior, it does not always refer just to bullets. It's basically the property of the behavior of the object of just moving across the screen as fast as it can. Basically, takes a speed, a velocity, and then just follows that speed throughout the environment. So I'm making my monsters move. I can add the bullet behavior to it. And I can also make the monsters, I can do the same with the bullet I'll move this out of the way. Well, what do we have so far? If we press play. One more behavior. So you don't actually see anything here, right? I'm actually moving my guy around, but we can't see him. There's one more. What behavior should we add to our game to actually see our player character? Any ideas? I'll select my player character. I'll add one more behavior.
But the bullet was visible from the.
Yeah, it was still visible there. Yeah. For the player character, I'll do scroll to, and this will scroll the camera to the player as the player is moving around. So now I have these three things: the controlling the player, bounding the player to the environment, and scrolling the camera to the player. And if we go here now, you can actually move around now. You can see that I'm moving in the world. And you saw this, the monster just ran away. I mean, it had the bullet behavior to it, so it just ran away. But we can do things a little bit more interesting than that. So we have added this to here. Let's see, I'm gonna add one more thing. I'm also gonna add inputs. I'm gonna add keyboard input and mouse inputs. Mouse input. So, with the monster over here, I can also clone it. So I can make many monsters just by control clicking, like that. And I can add more behaviors again. One of the things that I would like to do is to be able to shoot with my character. And I want to control the aim of my shooting with my mouse. So whenever I move my mouse, I want to change the facing of my character. And if I have this idea that I want something to happen when something else happens. If you can think about what you want in those terms, I want something to happen when something is the case. You're talking about what is called an event or a condition of some sort. It's an event that I move my mouse, that's an event, and I want that to affect some game object in the world. So in this game engine, you collect all of such events, basically the logic, if you will, into a special event sheet. So now you're talking about how the game really works. So if I open an event sheet, I can add events. And events are basically things that can happen, will have certain results. And I want this thing here, I want to be able to track the mouse and have it affect the orientation of my player. One of the events that happens in the game engine is simply time. Like time is passing. So there's a new tick of the game engine at the frame rate of the game. And you can have some things happen as a result of time passing. So you can do that through kind of connecting to the system. And you can find this ticking event in a list of system events. And a system event is here, something I want to happen every tick. And what do I want to happen every tick? I want my player to find the mouse and orient towards the mouse. That's one way to associate the mouse with the orientation of the player. So I can pick so I'm creating a new action, which is to reorient the player. So I'm picking the player as the one that the action is happening to. And I can find what action I can do on the player. One of the actions I can do on the player is to set angle towards a particular position. So I'll select that. And now it asks me, where do you want the player to look as a result of this action? I could put in a certain coordinate in my world to make the player always look at maybe 0.0 or some other place in the scene. But I can also, instead of putting a fixed number, I can give it the property of another object. And up there I can see what other objects I have so far in my world. One of the objects is the mouse object. And if I type mouse, I get all the properties of the mouse that I can use. And I can select the X coordinates of my mouse. I can also select the Y coordinate of my mouse. So now I'm giving it dynamic values, not fixed values, as the facing for my player character. And now I'm done. Click done. And so now the rule that I'm looking at here is that for every tick of the game engine, I want to set the angle of my player to the mouse location. And let's see what that looks like if I press play. So now when I move my mouse pointer around, the player character is updating its facing like that. I'm not shooting anything yet, but maybe I want to do that. So another event that I would want to maybe add to this world is a response to a clicking. And that is an event that the mouse provides into the game. So the event or the condition is some kind of a condition of the mouse being clicked. So I select the mouse as the condition for this action. I can select from different events that come from the mouse, like on click, for example. And I can say that I want the left mouse button to be clicked. And now I have created that particular event here. So I need to make a little more room here. So I create a new event, which is the left mouse click. And what action do I want to do when I left mouse click? Any ideas how you would go about implementing the shooting of bullets from the player? Let's say now that we've gotten this far and we can detect when you click the mouse button. What happens in the game?
Create an instance of a bullet.
Exactly. Think of the bullet as a game object, one of those objects that gets simulated. When you click a mouse button, you want to generate a new bullet. Basically, create a new game object. And then that game object does something. And if you click again, you might want to create another one, and another one, another one. So we are basically talking about some action that generates new game objects. And this generation of objects is called spawning. Like you've probably heard that terminology before. You spawn a new player in a game world, for example, but you can spawn any game object, typically in a game engine. And so as a result of the clicking action, you want the player, because the source of that new object is the player location, you want the player to spawn that bullet in the air in a way, and then send the bullet off. So we select the player as the creator of this action, and then we find the spawn action, which in this case is called here spawn another object. And we can now select which object to spawn, and we want to spawn a bullet. And we want to spawn it into our main layer. You see all the layers here, and they're numbered. Layer 0 is the background layer, layer 1 is the main layer. You want to spawn the new object into layer 1. And image point is something I will show you in a minute, but let's leave it like this. So now we have a bullet being spawned when you click. We can actually test this out. We should make sure that our bullet, our prototype bullet, which is this one, has a behavior associated with it that has, well, it already has the bullet behavior, so it should move when it gets created, but we can change the speed of the bullet. We can give it, for example, a bit higher speed. Let's try to play it here. So when I click, instances of the bullet object are being spawned, and they all get the properties that you set for that prototypical bullet that you had, that you're editing in the editor. But you see that the bullets are being spawned from the center of the object that I created. So they're being spawned inside the head of my player, but you would want them to appear from the gun. And that's what the engine was referring to when it was talking about kind of this point of origins. So if I edit my player character here a little bit, this is the image of my player, and here I have something called an image point. So for an image, I can create points in the image that I can refer to by other objects or other behaviors. And I'm going to create a new image point and place it here at the tip of the gun. This image point gets the number 1. There's already an image point called 0, which is the center, and now I create a new image point called 1. And now, when I look at my events and I edit this spawning of the bullet, I can change the image point for that spawning process to 1, and it will spawn at that location in the generating sprite. So if I play this again now you can see it's being spawned in the right place. That's all and good, but you could also see that all the monsters ran away immediately. They're just going in straight lines. Wherever I place them, because they have the bullet property, they will all think they're bullets, and they will just run as fast as they can in whatever direction they're facing. But you can also have them face, to begin with, you can have them face in random directions in the environment. And that you can do. That's sort of a part of an initialization of the system. So right now, I just place the monsters here. They're all bullets, and I start, and they all go in those directions. But maybe there are some initial settings of their movements that I want to associate with starting the system. So I can create a new event which I associate with the system start. And start of layout is one of the events I can associate with. The start of layout. And what do I want to have happen at the start of the layout? I want the monsters to pick an orientation, basically. So I can have them set a random direction, for example. Set angle to random 360. So when I start my level, each monster is going to run this action which sets its angle to any direction, basically random direction. And now they will go in these different ways. You can probably see it now. So now they're just going randomly around. And of course, the final thing to do is to actually be able to shoot them and kill those monsters. The essence of any game, it seems, is always to kill something that moves, but the only reason for that is that's the easiest behavior to implement. On collision, destroy. And that's the last thing we will add here. So we add, so what is that event that we want to capture here? What is the event that we want to hook into? Yeah, collision. and it's a collision between two game objects. It's a collision, yes, the bullet and the monster. So we can pick one of those objects. Let's pick the bullet. We'll create a new bullet event. So it's going to be dictated by the bullet itself. So the bullet is the object that the event is associated with, and the event itself is the collision. So on collision with another object, and we can pick any of the other objects. Let's pick the monster. And we are done with creating the event. The event is to link the bullet with the monster through a collision event. And now what happens as a result of this collision? That's what we add here. And what happens when the bullet hits? What are the actions we want to take?
So there's an explosion and delete others.
Exactly. We want to explode something, show an explosion, and we want to destroy whatever it hit with. So with the monster, we can create a destruction event. Destruction action here. So monster, destroy. And we should also destroy the bullet. So we'll do bullet, destroy. And we want to spawn an explosion. And we want to spawn the explosion from the bullet. So we use the bullet as the culprit here, and we find the spawn action for the bullets, and we have the bullet spawn the explosion. And we want to spawn it in layer 1. So let's see if this sort of works now. Oh, they all left me before I could even catch them. Wouldn't it be nice to get the monsters to come back? They all ran away and they never come back. So we can actually add that as well. If the monsters go outside the level, why don't we just turn them around and so they come back to us? So we can add another event that is based on the monster. And that event is going to be associated with monsters reaching the end of the world. So we can find one of these things is outside the world, is outside the layout here. And then as a response to that, we can even be kind of nasty and say, okay, if the monsters reach the outer part of the layer, turn around and run towards the player. That's kind of the nastiest thing to do. So let's pick a monster and we set angle towards a position. And the position in this case is the player location. So now they should come back. Oh. Yes, yes, they do. And we can try to destroy them. It's kind of a lousy explosion, isn't it? So let's fix the explosion. Here's our explosion sprite. This is our explosion sprite. And we can add one behavior to the explosion sprite, which is a nice visual effect of fading it in and out when it gets created. So first of all, let's just make it fade when it comes in. So it will appear to kind of slowly become visible. And then we'll also make it, let's see here, blend effects. So we will want the explosion to exist on top of the background. And so that there are some areas of the explosion that are see-through, and we want the background to show through when those see-through areas are in front of the background here. So actually what we're doing here is The blend mode is how we combine the pixels of the image with whatever image is behind it. And it will basically, the black areas of the explosions have the value 0, that's the color black. And so with the additive method of blending, then you're adding 0 to whatever color is at the background, and that's going to be the sum of, that's going to be the color, and 0 plus something else is really just that other color. So it's going to be the background color that comes through wherever there's a 0 in the image. So let's see if that looks a little bit better now. Yeah, there you go. So this was just a little bit of editing the properties of the explosion itself, the fade property and the blending property that allowed me to make the explosions look a little bit better. So now you pretty much have a game. And when you press the run layout, I didn't mention, when you press the run here, what this game engine does, created to, it actually generates an HTML5 page and then opens that page in a browser. So when I press run, it is running inside the web browser here as HTML5. And all of the behavior and appearance is all working. And you can go from here in a really straightforward manner. And I've not written a single line of programming code in the traditional sense of writing the program. I've been clicking my way through this like crazy. Setting properties, making game objects come alive. And so this can be a very fast and straightforward process. And you can play with it through the different tutorials that come with this particular game. Any questions about things I've shown? Okay.
We'll start with like free SDK or something in Crisis. Having Crytek. Could I make something and then buy the license and then publish what I made previously? Like, go back on what you've done. You would, like, you would have to have the commercial license the whole time. Yeah, you can publish something.
I would say it depends on what you're doing with the non-commercial license. I think as if you build a game company around it, and you maybe you are sharing your creation as a future game, maybe that you might be crossing the line a little bit. So if the intent is clear that you're using it as I say, a marketing tool, it already has some commercial value to it at that point. So I don't think you could do that. But I would say that if you are experimenting with some pieces of technology or something, you could use the free non-commercial version to do that on your own at home. And then in this case, in fact, if you're working with CryEngine, the commercial version only costs you like a few dollars.
Like a monthly thing?
Yes, it is.
They get royalties.
Then they get royalties.
Right.
And it's the same with the Unreal Engine. You get to use it more or less for free or for a very low cost, but they'll ask for royalties basically from users. But I think definitely in order to pick your right engine and see what engine really, what they support and whether they will support your creation well, you can use the free version for that to experiment. But of course, as with everything else, you want to support the developers of these things, and so even with this tool here, if you're feeling really like that's the tool I want to use, I would encourage you to pay maybe some of the fees that they're asking for, so they in turn can improve their engines and you become a part of their support network, and that's kind of a nice place to be in as well. So I think any other questions? So this is really the end of the presentation, and which I started by just talking about what a game engine is and how you change content to run any game you want. And now what we've been seeing examples of are 3 different game engines, and we are playing with the content. And you can sort of make your own games that way. If there are no other questions, then just thanks for this, and good luck with what you pick. And also, if you're interested in kind of finding game engines out there, there's also this here list. The game engine list. on Wikipedia, and it organizes the game engines. Here we have the free game engines. It gives you some information about what platform they're running on and so on. And you can see the number of free game engines is quite large. Quite large. And then you have commercial engines. And the commercial engines, like the Unreal Engine and the CRYENGINE, will still allow you to use them for free for non-commercial purposes. And then there's a lot of these engines as well. So you might want to look into the different options here. And you can also contact me if you have further questions. I can be of support there in this game theater if you like. My address is hannes@ru.is. So thank you very much.
Thank you. Thanks. Great talk. We are over time, so I'm just going to end this here and see you on next Saturday. On Saturday after a week, Ari is going from Artmannarskólinn. He's going to talk about artworks, 3D art, and show you what tools are very useful in this, making these arts. So next Saturday, see you then. Thank you.